excuse. How do we know there's a God? There's a universe. Therefore, there has to be a creator of that universe. And that was the eventual goal. That was the goal, is humans on the earth. And must first create, as I said, space, time, matter, and energy. Before God created these things, there was no space, there was no time, there was no matter, and there was no energy. So all these things had to be created first. And then God had to create the four forces which holds all matter together. And they are gravity, electromagnetism, which is, of course, electricity and magnetism, the strong nuclear force and the weak nuclear force. And these are the four forces which hold the entire universe together. Now, how they work, we don't know. We just know they do work. And really, we don't know how they work. We know a lot about them. For example, the strong, electromagnetic, weak, and gravity. We know the strength, the range, the particle. We got it all figured out. But how it works, besides this description, we don't know. And there's strong nuclear force, which holds the atom together. Isaiah 40, 21 through 23. Had it not been told to you from the beginning, had ye not understood from the foundations of the earth? It is he that sitteth upon the circle of the earth, and that stretched out the heavens as a curtain, and spreadeth them out as a tent to dwell in. And that is a good indication, it's a good account as to how God created the earth. Could God create an earth that looked like that? Well, could have, I guess, but no. The earth is round, gravity pulls the earth together, and it stays in the round shape as a result of gravity. How you make ball bearings is kind of intriguing. You melt them in a long tower, and then you extrude so much metal, and as they fall, they become round because of gravity, and then they hit oil, and then they're solidified. So that is how we make perfectly, or close to perfectly round batteries. So, the round earth is really, because God made the laws, therefore he has to make the earth and the universe to respond to those laws. And therefore the earth has to be round. What is the origin of the moon? Well, there are a number of theories, and this is a good illustration of the fact that we don't really know the origin of much in the universe. There's a lot of guesses, there's a lot of theories, but one of the best examples is the moon. There's the moon. And now this is the one that's most widely accepted today, and this is called the giant impact hypothesis, where something ran into, there's the something, ran into the earth, knocked a huge chunk out of it, there we go, and that huge chunk all reassembled together, it was circling the earth for a while, all reassembled together, and finally we have the moon. There's a man by the name of Velikovsky who a few years ago hypothesized a similar argument, and he was laughed out of science for decades. How many ever heard of Velikovsky? Anybody? Okay, he wrote The Worlds in Collision and 4 or 5 other books, and basically they said this will never work. It was foolish. In fact, they had debates on whether or not they should allow him to present his ideas at meetings. And they concluded he shouldn't because this was way out of line. Ironically, they are now proposing the same theory, and I have the same objections they did to Velikovsky. This is just not realistic. Well, what are the other theories? Well, one is that the moon was a planet called the capture theory, small planet that was roaming around in our universe, and it got too close to the earth, and it was captured, and that's called the capture theory. To me, that makes more sense from an evolution standpoint. But of course, from a creation standpoint, God created the earth, and then God created the moon. And another one is the fission theory. The earth was spinning around too fast, and because it was spinning around too fast, it ejected some land, which became the moon. And there we go, there's the moon. And eventually, we had a separate body. The problem is that the moon is in many ways very much like the earth, as far as rocks are concerned. In some ways, though, it's very different from the earth. So no theory really fits perfectly well. Although the catastrophic theory now is the most widely accepted. And the Earth, of course, and the Moon has to orbit the Sun. How does that work? It works very simply. And the best illustration is we have a cannon. A cannon shoots a ball. It falls here, goes so far. More force behind it, and it falls later. Even more force, and it falls at the same angle of the Earth. So the answer is, why does the Moon stay up there? The Moon circles the Earth. It stays up there because it is falling. It's falling. That's why it stays up there. It's falling. It just falls at an angle which it never crashes into the Earth, or at least scientists say not for a while. And gravity is critical to holding these parts together. And this case must rotate the Earth in 24 hours. Mercury, it takes 2 years for its satellites to roam. Venus, the rotation takes 2 years. So 1 day in Mercury would be 2 years. Venus would be 5,832 hours. So the Earth's rotation, 24, is perfect for the Earth. Why do all these other planets exist? What is the purpose of them? Well, there's the Earth. And the reason they were created was because they serve as an important means of protection against meteorites and stuff from outer space from hitting the Earth. Jupiter's gravity is enormous, and when meteorites are traveling toward the Earth, most of them, not all, but most of them are absorbed by Jupiter. And when we look at the craters in other planets, we see most have a lot of really major craters. We have 3 major craters that they know of on the Earth. So we have a few, 3 major ones, but by and large, there are very few craters that have damaged the surface of the Earth. And there you can see the Moon, covered with craters. Lots of craters. So it's had lots of activity. The Moon's function also is to protect the Earth from asteroids. And the planets rotate as a system, and we can see that the design is such where they all have a role in the existence and function of the Earth, by the way, which is right here. And you can see how large these 2 planets are, Jupiter and Saturn, compared to the Earth, and even Neptune and Uranus. And therefore, they are very effective in protecting the Earth. And we are right here. That's where the solar system is. We are part of the Milky Way galaxy. And what is the purpose of the Milky Way galaxy? Well, it provides stability. One issue you have when you create planets and suns and stars is stability. How do you achieve stability? Well, you can't park them and they'll sit there forever. That doesn't work. What works is movement. And a good example is a bicycle. If you set a bicycle up, it falls down. If you ride the bicycle, it moves. That provides stability, and therefore, that is how the universe works. Provides stability. And there, at top view, you can see this is where we're at in the Milky Way galaxy. And the Milky Way galaxy itself also rotates, again, supplying movement, which allows stability to exist on the Earth. So God had to create not just the Earth, but the solar system and the Milky Way galaxy to achieve the stability necessary. And we are, our galaxy, the Milky Way, is in a group called the local group. And this whole group, likewise, also rotates. And so we move in like 9 different directions at different speeds in every second that we are alive. And now there are billions of galaxies. As far as we know, the whole purpose, again, is stability. For, as far as we know, just the Earth. And the galaxies we now know are moving outward from the center, and that movement outward provides stability. Now, how do you hold all these galaxies together? Well, now we know there is what they call dark matter. It's called dark because it doesn't give off light. So it's called dark matter. And we know it's there, or at least the theory is it's there because it has gravity. So no light, but has gravity. And they've put this all together, and we can see here all of these strings which holds the universe together, and these illustrate the strings. And these strings are a result of dark matter. Now, back to the Earth. We live in what they call the habitable zone. And here's where the Earth is. It's just right, closer to the sun, too hot, too far away, too cold. So we live in the Goldilocks temperature zone, which allows Earth to be just right. And if you think about it, I know it gets cold some places, it gets warm some places, but the range of temperature on the average is really fairly narrow. Not really very great. Some of the planets you have temperatures 1,000 degrees below zero, or hundreds of degrees above zero. On the Earth, nothing even close. On the Earth, basically, we're talking about 10, 20, maybe 30 degrees deviation in either direction in most areas of the Earth. Earth is called the water planet. It's the only planet, basically, that's covered. About close to three-quarters of the Earth is covered with water, including all of the oceans and rivers and the Great Lakes, etc. So a good deal is water. And if you compare the Earth with other planets, you can see that most planets have very little, if any, water on them. Okay, where does the water come from? Believe it or not, scientists don't know. One theory is comets. Many comets are largely water, and therefore they would supply one source of water. The problem is that water in comets have a high level of deuterium, known as heavy water, and that's not going to work. We have a little bit of heavy water, but not much. We have water made out of not deuterium, which is the hydrogen. Volcanoes, well, that's one theory. Volcanoes. Outer space, that moves the problem elsewhere. In the end, like we don't know where the moon came from, we don't really know where water came from. And that is an idea which there's theories about, but there's no clear consensus on whether that's the case. When you look at all the other planets, even first graders can pick out easily, where's the Earth? Well, right there, must be right there. How do you know? Well, it's blue. It's a water planet, it's blue. All the other planets are rather forbidding. They don't look welcoming at all. The Earth looks clearly very welcoming. And also the Earth is the only planet where fire is possible. It's the only planet where we have 78% nitrogen, 21% oxygen, 1% argon. And why is that so important? Without fire, we would not be able to heat metal, to make metal molten. Wouldn't be able to cook our food. Wouldn't be able to keep warm. Fire is critical for life on the Earth. It's critical for industry. To burn coal, to get energy, to run trains, generators, etc. So the Earth is the only planet where fire is possible. Now, if you had a planet which was 85-90% oxygen, well, that wouldn't work because it would probably blow up. So you need the right amount of oxygen, which is about, right here, 78, 20% oxygen. And therefore, that's the only one that works. And Mars' atmosphere is 96% carbon dioxide. Well, forget about fires. It's not going to occur on Mars. Now, nebulae, now we'll go out in the outer space again. And nebulae, they have found incredibly beautiful pictures of the world outside. And this picture here is called the Pillars of Creation. And this is gas behind it that lights up, and therefore we get this beautiful picture. About 7,000 light years away from the Eagle Nebula is this guy. And the longest pillar right here is 4 light years long. This is 4 light years long. It takes light 4 years to cross from here to here. Okay, now this one, when this was discovered by astronomers, they looked at this and said, what is it? What is it? And he thought it must be the Eye of God. And that's what he named it, although it has an official name elsewhere, but he named it the Eye of God. And the astronomer, when he discovered this, couldn't sleep for 3 days. The eye of God. Now, of course, we've seen this before, and this is widely known among us. But to be the first to discover this would be, as one astronomer said, worthwhile for a lifetime of staring at the stars, and discovering nothing. This makes it all worthwhile. So a lifetime of searching and a discovery like that, he'll probably, on his deathbed, he'll probably say, well, I discovered the eye of God, and it makes all the time I spent staring through a telescope worthwhile. And indeed, it did. Now we must have an atmosphere as well. And we have a exosphere, thermosphere, mesosphere, stratosphere, and troposphere. All of these are necessary for life to exist. Some of the planets have atmospheres, thin often, but they must have this combination in the correct proportions in order for life to exist on the Earth. So remember, God had to create not only the Earth and the universe, but also the atmosphere with the goal in mind of creating man. So it was a while, well, 6 days, of course. It was a while from God's standpoint. It was a while before, indeed, the life, humans, could have been created on the Earth. We must have a sun, of course. There's about 100 trillion photons arriving every second at every square centimeter of Earth's daylight surface. 100,000 trillion, did I get that right the first time? Every second, for every square centimeter. So we're talking about an enormous number of, well, quintillion, I guess, of photons hitting the Earth every second. And we must have an ozone layer to protect the Earth from the radiation from the sun. The sun produces a number of radiation levels, and some are necessary for life, some are problematic, and this ozone layer makes sure that the problematic, the cosmic radiation that causes cancer, is largely filtered out, at least to a large degree. That's the ozone layer. Greenhouse effect, you hear a lot of nasty things about the greenhouse effect, but if it wasn't for the greenhouse effect, life would not live on the Earth. We have to have more heat than the sun would give us, and the greenhouse effect traps the energy so the light from the sun adds up, keeps the Earth warm. And we hear a lot about global warming now. The scientists know that in the end, the real problem has and will be global cooling. The Earth is cooling. It just has a bump in becoming warm because of, evidently, the greenhouse effect. And you in California are very aware of this because they talk about it constantly, as if that's the only important issue. It's the greenhouse effect. And that's why I understand in, 4 years, they say, we're all going to have to buy electric cars. Yeah. And that's why so many things have been issued in California to try to deal with the greenhouse effect. Well, I think maybe they should look at other problems, and in the long run, this greenhouse effect may be beneficial. Think of other ways of reducing it. We have a magnetic field called the Magnetosphere, and that basically is where this magnetic field, because the Earth at the core is a magnet, and that magnet basically allows this field to form, and what happens is the cosmic radiation doesn't get to the Earth. Now we've got the ozone, but we need more protection. So it therefore ends up over here at the poles, and then we have the aurora borealis. And here you can see the solar wind, and you can see it accumulates here and here, and also most of it does not accumulate in the areas that receive a great amount of electromagnetic energy, or electrical energy. Okay? The Earth's magnetosphere is a vast comet-shaped bubble, and it plays a critical role in our planet's able to inhabit. They talk about inhabiting Mars. Mars does not have this whole system to protect itself. And a concern they have is that if we lived on Mars, we would end up dead because of radiation poisoning. So they have to protect us on Mars against the radiation poisoning, which I think is an exercise in fertility. But anyways, nitrogen, lightning fixates nitrogen, and when I present this, that surprises people because so many people feel, well, lightning is bad. Starts fire, it does. Kills people, yeah, it does a few people. But the farmers know better, and when I talk to the farmers, they say, after lightning, we thank God. Thank God for lightning because it fixates nitrogen and fertilizes the crops as artificial fertilizer could never, ever achieve. We put ammonia on the crops as fertilizer. Well, this is a free source of fertilizer.
Jerry, what does fixate mean?
Fixate means we convert the nitrogen from the atmospheric nitrogen to a form that can be used by plants. Atmospheric nitrogen, fortunately, needs to be fixated because if it didn't, lightning would strike the earth and the earth would blow up. Nitrogen, they make nitroglycerin out of that. They make dynamite out of that. So nitrogen is highly explosive. So it has to be put together for the atmosphere in such a form where it is not readily able to explode. Basically, it has the 3 bonds. The 2 nitrogen atoms are held together by 3 bonds, which is quite strong. And so therefore, fixation is what breaks those bonds and produces nitrogen so that it can be used for fertilizer, which is what it is. And that's why after a good lightning storm, you'll notice how green the plants get, how green the fields get, and that's why. So next time at lightning, well, stay inside, protect yourself, but thank God for it. Okay, nitrogen cycle, and nature recycles everything. Everything is recycled. Nitrogen is recycled, water is recycled, everything is recycled over and over. So it rains, the water flows down through the mountains, back in the water, it evaporates, an engine driven by the sun, clouds, rains, it goes round and round and round and round. It's said that when you take a drink of water, some of those molecules that you are drinking would have been molecules in Napoleon's or Caesar's or somebody else's body. Because it's been circulated over and over and over. And this one thing I like about California, they stress recycling, and I think they ought to stress it more. Stress recycling. You should recycle everything. I grew up in the city, suburb of the city, and we recycled everything. We didn't have trash pickup. It didn't exist. The organic garbage I buried in the back, we had a garden, and paper we burned in a tank. Everything recycle everything. Why don't we today recycle everything? Why not? And the earth is created to recycle everything. Carbon cycle, heat cycle. Now, source of heat. People who are opposed to radioactivity from uranium, etc., I wonder because what do you think you are sitting upon right now? Right below us. I should have brought my Geiger counter and I could prove that. You are sitting now on a nuclear power plant. How do we know that? Dig a hole 3-4 feet down, it's warm. Where I live, it gets pretty cold in the winter. Dig a hole 3 or 4 feet down, it's warm. Where does the heat come from? It comes from the atomic energy plant right below the land. 3-4 feet, never freezes. Call that the frost line. It doesn't freeze because the thermonuclear plant right below you right now is producing energy to keep the earth warm. And so I don't understand when they talk about the dangerous radioactive materials like uranium and thorium and so on. Well, why don't we just put it back where you got it from? They mine it from a hole, they bring it, they process it, they use it to run the nuclear power plant. Why don't you just take it back? So we just give it back to you. You have all this, it's waste, it's not that radioactive. So what we are doing is safer than the material we remove from the ground. So just bring it back. And we tend to get paranoid about radioactive materials. Be careful, but on the other hand, there's the Earth. And the Earth is designed in such a way to where, besides radioactive energy from the radioactive decay, we also have all these other parts which is what cause it to work the way it does. Now, volcanoes certainly are not good. Actually, volcanoes are really critically important because they bring up minerals you need to farm from the earth, magma, minerals. The minerals are brought up by the volcano, and guess what? After an eruption, this area here is really, really fertile. It's got all the good minerals it needs to produce really good crops. And that's why we build farms by volcanoes. Well, you've got to be careful and, make sure they're not too active and they start to rumble, you might have to leave. But on the other hand, Volcanoes are a very important source for fertilizer for the earth. So they're not there for no reason. They're there for a very good reason. You just have to be prudent, like everything else, and don't end up. Okay, here, repetition. Earth is the only planet on fire. And don't have enough free oxygen in most places. The more oxygen, the hotter the fire. What do we use fire for? Heat homes, cook food, melt steel, gasoline, jet engines, electric light bulbs, and on and on and on. A welding torch burns at 5,500 degrees Fahrenheit. A welding torch would not burn at all on none of the planets that we know, only the Earth. And God also had to create not all the other things, just the other things we talked about, but God also had to create the 100 or so elements. All these had to be created. And if you study chemistry, I taught chemistry, so we got aluminum, we got thorium, we got potassium, we got sodium, we got zirconium, we got all these, zirconium, that's not an element. We got all of these elements, which are all very important. The rare earths over here, we did not think were very important for very long. And now we have our phones and color TVs, and now we know the rare earths are critical in order to get those phones to work. So the rare earths are really a very important part of our world today. So just think, God thought way in the future, and let's see, when they invent cell phones, I want it to be pretty. And maybe I'll develop a few other elements so that they can have some pretty screens for their cell phone. Well, they're there. And why are they there? Well, God put them there, so there we go. And that's all the elements. The ground, the earth, the 10, 15 feet of topsoil, what's there? Well, a lot of oxygen, a lot of silicon, oxygen necessary for life, aluminum, not necessary for life, iron, or necessary for life, calcium necessary for life, sodium necessary for life, magnesium necessary for life, potassium, thiamine, and hydrogen, all necessary for life.